For those watching the video, remember to skip that first part. Now I can cut things out. See, but that'd take more work, right? Well, there's our book. Imagine that. Okay, section 1, the mathematics of voting. So we have a democracy, and in democracy you have the right to vote. We vote in presidential elections, gubernatorial elections, local elections, busing elections. American Idol? Yeah. In the summer, we had as in Connecticut, in the fire district, had a board consisting of 5 members. And the 5-member fire district board voted a 3% pay raise for the firemen, a contract that said 3% pay raise for the firemen for the next 10 years, every year. Now, do you like such a contract? Oh yeah, you probably would. That's pretty fun. This was a poorer section of Connecticut. It wasn't the rich section of Connecticut that has all the millionaires on the West Coast. And the guys from the projects, the poor people in the projects said, no, we don't want that. So they petitioned the board to increase the membership of the board from 5 to 9. And they had a public meeting, and in order to vote during the public meeting, you had to be a taxpayer or registered to vote in the fire district. So I because I own property, I don't vote there, but I could be there. And at a normal fire meeting, there is 10 people that show up other than the board members, right? There are 250 people there. The 250 people voted 202 to 59 or whatever to increase the numbers of members on the board. As soon as that was done, then we went into the immediate nomination process of who the members were going to be, and the new members were. And we nominated 4 people from the floor. The people that lost the election walked out. We nominated 4 people from the floor. They were elected to be on the board. And at the next board meeting, there's now 9 members. 5 of them are going to vote no on the contract. 4 of them who voted for it the first time are going to be outvoted. And because they didn't have the attorney present when they did the contract was written in a way that it can be thrown away. So that's democracy in work. You know? So, but we vote on those things. You know, somebody saw a loophole in this process and said, we're not going to let this. What used to be a volunteer fire department is now taking over 50% of the funds going to the property taxes. Every time you call 911 and the ambulance shows up, a fire truck shows up with it, because that's what the union contract says. And we're not going to do that anymore. And so we didn't take it. The paradox is that there's more opportunities we have but to vote. We have less appreciation of the understanding of the vote. I mean, why should we already knew who was going to win the election, right? Why should we vote? I'm in Nebraska. I knew the Republican was going to take Nebraska. You know, why should we vote? You know, I knew that the Republican was going to win the Senate seat. You know, so because I knew that, I went in the second week in October and voted early because they had early elections. Yeah, so I wouldn't have to vote on the day it was. Does your vote count? So the first part of voting is voting. The second half is counting. For those that watch the new show Vegas, they just had a mayoral election. They managed to move in some voting machines from Chicago that was pre-votes already stacked in it, and the new guy that the mafia wanted won. Oh, that was good. So there's the voting part, and then there's the counting part, right? Arrow's impossibility theorem, the method for determining election results that is democratic and always fair, is a mathematical impossibility. What? No? Wait a minute. You mean when the ancient Greeks took their white stone and their black stone and they walked in and they put it in the pot to voted whether or not they're going to go out and fight the Persians as they're coming? That election was rigged? Well, it might not have been, but the results being always fair is what it's saying. So it might be fair in some cases, but for it to be always fair is a mathematical impossibility. When we vote for president, does the popular vote count?
No.
No. So only electoral vote is going to count. So if California goes 100% for one party, there's not much the rest of the country is going to do except go that way on the popular vote, but that might not be enough to believe in it. So anyway, so I'm glad you're in a class where mathematics is impossible. Yeah, really good. Okay, well, I'm glad we covered that. So we have preference ballots and preference schedules. So if I could spell that, if I pronounce that word, polarity, not polarity. Well, anyway, whatever that word is, English is not my major skill, and I got straight D's in French. So and because I'm an electrical guy, I want to say it as an electrician type stuff, but it's not. Plurality. Plurality. That's close. So that means you have the most. So we're going to vote on something in the room, and three of you vote one way, and two of you vote the other way, and one of you don't vote. The three have it. If two of you vote one way, two of you don't vote, the other two vote a different way but different, and only two people would have it. That's what that means. Then we have a Borda counting method. Never heard of it, I know. Neither did I 2 years ago. Then we could have a polarity, whatever the word is, with elimination. Because there could be a runoff election, because we might have to see who made first, second, and third place. So, the second place guy is going to be the vice president. Well, we have to figure out who the president is and before we figure out who the vice president is. Then we have a method called pairwise comparison, which we're going to go and take each candidate A, and compare them against the other candidates and see where they pair up, and we're going to assign votes to it, and then we're going to have some ranking systems, more than one, and maybe by the end of the day we might actually add, subtract, multiply, maybe even divide. Who knows? Luckily I got my calculator. I better pull it out just in case, and I'm all set, because it has to charge up in the sunlight, right? Because it's one of those guys. All right, so I'm all set, just in case. Okay, so we have a math club election at some university, and we have 4 candidates, A, B, C, and D. Alicia, Boris, Carmen, and Dave. And 37 members are going to vote. And we're gonna vote for first, second, third, and fourth choice. Now, when was the last time you had an election where you voted for first, second, third, and fourth choice? Never, right? But if you were doing some, you're trying to figure out who's the number 1 basketball team. The sports writers might do that. They'd vote for 1, 2, 3, and 4, and then do a counting that way, or who most valuable player or something like that. But in general, we don't, as normal human beings, we don't do that. But for some reason, they're going to do that. And the next slide's going to show the results. It's decision time. Who's the winner? All right, so there's my ballots. Isn't that lovely? This looks like an accounting class, right? So I hope the next slide does something cool, like puts all the ballots that are the same together. You think it will?
Hopefully.
Oh, it didn't. One of them should, though. Um, so the choices, blah, 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 ballots, preference ranking. There we go. So there's 14 ballots that go A, B, C, D, and 10 that do that, and 8 that do that, and 4 that do that, and 1 that does that. Isn't that wonderful? So who should win the election? Well, A has more first choice picks, but B has more first and seconds than A. Look at A sitting down there. Nobody likes A, except for those 14, right? But there's all these other people that hate A. You know, who's A? That was Alicia? Yeah, she's probably got blue eyes or something. And there's probably only 14 boys they all voted for. Is that what happened? I don't know. But you sure that Alicia should be our win?
No.
You're not so sure anymore. All right. Math Club 11. Transcenticity and elimination of candidates. Transcenticity. Voter preference, A over B, B over C, then automatically prefers A over C. Okay, so if I prefer B better than C, then elimination. Relative preference are not affected by the elimination of one or more candidates. So if B gets eliminated, I went C, B, D, A. Now I'm going to go C, D, A, and I'm in the same order. All right, well, okay. I guess I can do that. The next section will return to the business of selecting who's going to win this. Oh, next section. I understand. That means I go to the next section. Can I open it, or is it sitting in some file that I can't get to? Oh no, I can open it. Section 2. Okay. Polarity. Maybe that's what it is. So that's going to be our first method. A wins when I use that method. I just know it. The candidate with the most first place votes is called the polarity candidate and wins. We don't need each voter to rank the candidates, because only one is going to win. We didn't have to waste all of our time doing all those other things. This is the way we do it in every single state in the union for just about everything. Okay? Except for senator in the state of Georgia. If the senatorial race, if you don't get more than 50% of the votes in the senatorial race in Georgia, there's a runoff. Yeah. In the state of Nebraska and Iowa, if the guy gets 47% of the vote and he has more than anybody else, he wins. Okay, so third and fourth party candidates, it doesn't matter. You could win with some lower number of votes. When it was, let's see, Adolf Hitler was elected to be chancellor of he lost the election, by the way, but on losing the election to be chancellor before he became chancellor, he got a certain percentage of the vote. What president of the United States got the same percentage of the popular vote, 37%? Anybody know? Abraham Lincoln. No, George Bush got over 50% of the vote. Yeah. And in fact, we don't know. We really don't know, because do we ever, in the United States presidential election, do we ever count the popular vote?
No.
No, that's right.
Oh,
So if I'm sitting in Chicago and I have one candidate and I'm sitting in Illinois, and I have one candidate with 63% of the vote and the other candidate with 30-some% of the vote, I never open the absentee ballots because they wouldn't matter. So we normally don't count the absentee ballots except in elections where it matters. Because we don't do that, we really don't know what the popular vote is. And so if you go to the Bush-Gore election, you can, one side will say, well, the George won it by 1 million votes. The other side will say Gore won it by 1 million votes. But the fact of the matter is we never bothered to count it. because state by state, municipality by municipality, we never opened them if it didn't matter. It mattered in Florida, and we opened them. What a mess. Anyway, vast majority, that's the way we're deciding. But there's drawbacks. It is simple, but there are drawbacks about it. So A, who's hated by everybody except the 14 people that cast the first place votes, won that election. Alicia is the president of the math club. She didn't get the majority, but she got more votes than anybody else. Okay? The majority candidate, the allure of this method lies in the simplicity and the fact that this is a natural extension of the majority rules in a democratic election between two candidates. This seems like a really good idea. When there's more than that, it may not be such a wonderful idea. The problem is, if you actually get the majority of the vote, then everybody's going to love you. But if you really got through on 1/3 of the vote because there's a whole lot of other candidates, then that might not be so wonderful. It'd be more difficult seeing it your way. The majority, the rest of the math club said no to Alicia, and she's the winner. So that's the problem. I'm sure he can get around it. This violates the majority criteria in an election where there is a majority candidate, but the candidate does not win the election because of something. If this happens under some voting method, you say the voting method violates the majority criteria. The majority didn't like this person, but she got elected anyway. But it satisfies our concordant criteria. The principal weakness is that it fails to take into consideration the voters' other preferences. Not that we care. Most of the time we just don't care, right? Like, who cares who's the math president, right? Of the math club. As long as they never took a math class, right? So as long as the Christian club's president is some Jewish guy, that's fine. And as long as the Jewish guy has some Islam guy, the president, that's okay. But can't have you know about that, right? Yeah. Not here. You can do whatever you want here, but no one tells you something. Okay, so what do we got? We have the bowling season. Coming bowl season, the Rose Bowl. Oh, right. So we have a Rose Bowl, Hula Bowl, Fiesta Bowl, Orange Bowl, Sugar Bowl. An election is held among 100 members of the band to decide which bowl they should go to. Anybody play in the band? Did the band director ever ask you where you wanted to go?
No, because we didn't have that big of a band.
That's right. So you went wherever he told you, right? Mm-hmm. Yeah. So this is made up too. No band ever gets to vote on where they're going. So
we're never special enough to go anywhere. So
that's right. So here we have 49 people, 49 voting for the Rose Bowl first choice, and whatever the S guy is on the bottom, and 48 says Hula Bowl first, and the Rose Bowl on the bottom, and the Fiesta Bowl first for 3, the other guy on the bottom. So that's my preference. And we have to decide who won the election. And again, Rose Bowl is sitting here on the bottom for the majority, but also gets 49. But Hula Bowl, first and second choice for everybody, first or second. So I would hope I could come up with some way to count these votes so that the Hula Bowl wins, because I think that would be best for my band. So Plurality, Rose Bowl wins. But it's a bad outcome. 51 voters don't like it. Hula Bowls has first and second close votes. That should satisfy every much better choice. And of course, the bandmaster is going to go to wherever he wants to anyway. So we're going to do a head-to-head comparison. So we look at hula to Rose Bowl, and the hula bowl runs 51 times, and hula to Fiesta, and I have 57 times, but 97 times, and hula to Orange, all the votes beat that, and hula to Sugar, they all beat that. So no matter which bowl is compared to the hula bowl, there is always a majority of the band that prefers the hula bowl. Now the issue is, can I do that on paper? Especially if there's 30 or 40 choices. I don't know. Condorcet Criterion. The candidate preferred by the majority of the voters over the other candidates when the candidates are compared head-to-head comparison. This is called a Condorcet candidate. If a candidate is preferred to the voters over the other candidates in a head-to-head comparison, then that candidate should win. Violation. Example 1-3 illustrates a violation of this method. So 1-3, that's the one we're working on with the hula bowl. It says the Rose Bowl wins, but in a one-to-one comparison, the hula bowl would win. It should have won. Just because a violation occurs, that doesn't mean that it should happen that way. So if we go back to something important like the end of Prince Caspian in the Tales of Narnia, Chronicles of Narnia, the line says things never happen the same way twice. So you could have the same election happening next year with the same results having a different candidate picked because you picked a different way of counting. Yeah, isn't that great? Insincere voting. All right, so the idea behind insincere voting as a voting strategy is that we're gonna vote for somebody to give our candidate a better chance of winning. So instead of we're not going to waste our vote on our favorite candidate, because if we do, he's going to win. We're going to vote for somebody else, the lesser choice, to make our candidate look better. Clearly, if you're doing that as a one-on-one type thing, a person, it's not going to work very well. But in smaller groups, you could probably influence an election that way. So the marching band's going to get that election is going to be manipulated by the trumpet section. It's 3 of the band members realize, can't touch that. 3 of the band members realize that there's no chance that their first choice of the festival can win in this election. So rather than waste their vote, they decide a new strategy, and they're going to vote for the hula bowl. They cast their votes for the hula bowl by switching their first and second choices on their ballots. Okay, that's what they're going to do. Now, how would they be smart enough to do that? I don't know. So this is how it was the first time, but now we're going to switch our first and second choices to the hula bowl, and now the hula bowl comes in first. Okay, so as soon as I figured out that I can't go to the Fiesta Bowl, 3 people, as soon as I figured out that wasn't going to win, and if I didn't vote for the hula bowl, the Rose Bowl was going to win, I switched my vote and manipulate the election. Oh, how wonderful. So just the simple switching of 3 votes changes the outcome of the election. This is a major flaw in the election. So manipulating a voting block of voters with insincere voting is an interesting idea. Sounds like something we ought to try. Insincere voting is common in real world. 2000 and 2004 presidential elections, close races. Ralph Nader lost many votes. because people thought that they were wasted on him. And same thing with third-party candidates and small candidates, never get their fair share. If they don't get 5%, then they don't get federal funds next year. When have they ever gotten 5%? The entrenched two-party system often gives little choice. You got to vote for one of the two parties. Your vote's wasted, and then the whole media tells you it is. Did I tell you I'm running for president next election cycle? Didn't tell you that, did I? Oh.
I wanted to vote for Nate and Elliot.
Yeah.
He wasn't running.
Here we go. This is my party platform. Get a budget. Balance the budget. Pay off the debt. There we go. I'm running for president. That's my party. That's my platform. That's all I'm going to say. Go ahead. Ask me some political question. Go ahead. Anything. Well, I'll ask myself a question. All right. What do you think about gay marriage, Doug? Until we get a budget, who the heck cares?
Yeah, that's no joke.
All right, how about another question? What do you think about funding of the military? The military, they should all be put back in the barracks until we have a budget that's balanced and we get this debt under control.
Only it works like that.
Yeah. So, anyway, my generation, you know, I'm too old. Not my problem. You guys feel sorry for you.
We're screwed.
I know. I mean, how could you possibly think it's okay to be without a budget for 4 years?
Now, the $400 and some odd $100,000 that he's going to get from the rest of his life.
Yeah.
Cut it and make him pay off the
Oh yeah, that's right. Part of my get a budget thing, we're going to cap federal retirement pay. I'm going to cap it at $50K. Making more than $50K, fine. It goes down 5% a year every year until it gets there. There's 100 people right now getting over $200,000 a year in retirement checks from the federal government.
Which isn't right.
Is that which one of you guys are paying that? Yeah, all of you, right? For suckers. I mean, isn't that wonderful that we are doing that for these really great guys? Yeah, but it's not. You're right. It's not right.
I make $11 an hour and they take over $2 an hour out in taxes.
Yeah, I know what you mean. Oh, I get to teach this class, and all it does is just turn off. Oh, we're done. Let's see if we can work a homework problem. Change the status of things. Maybe things will be better. So that's how I'm running for president. That's my my campaign slogan there.
I'll vote for you.
Yeah, I think I'd get enough votes. I really do. The media would laugh me out of the world, but that's fine. Okay, we're gonna start with problem number 1 and hope for the best. I have no idea.
29.
Oh, look at that. Isn't that lovely? Figure 1-6 shows preference ballots with, see what it says there for above the A? It says walking. So these homework problems are walking problems. And then later on page 38, we have jogging problems. And then on page 40, we have running problems. Okay, so as long as we're just walking, they have to be simple. Okay, so number 1, write out the preference schedule for the election. Okay, so that means this means busy work, right? All right, so I'm gonna go C, E, D, A, B. I've got one of them. And then I've got A, D, B, C, E. I have one of them. I hope I don't have too many of these guys. Then I've got a B, E, A, C, D. I got one of them. And then I've got A, B, C, D, E. I have one of them. I better start getting an extra. Okay, here we go. I got this guy is the same as him. This guy, oh, I got a new guy. D, C, B, E, A. Got one of him. Right, I've got a A, B, C, D. Okay, I already got that guy. A, B, C, D, E. So I got him. And now I'm on the second row. B, E, A, C, D. That's him. A, B, C, D. A, B, C, D, E. That's that guy. D, C, D, C, B, A, E. I don't have that guy yet. D, C, B, A, E. One of him. D, C, B, A, E, A. E, A. That's that guy. A, B, C, D, E. That guy. C, E, D, A, B. That's that guy. A, B, C, D, E. I like the A, B, C, D, E. That's easy. What, everybody following what I'm doing?
No, you missed one.
I missed one already.
B, E, A, C, D.
B,
Oh, no, never
E,
mind.
A, C, D. Right
Never
there.
mind. I'm good.
Okay, so what I'm doing is I wrote down the list of what they are. Now I'm getting duplicate guys out of my stuff. So I'm in the third row. B, E, A, C, E. Right there. C, E, D, A, B. Right there. A, B, C, D, E. Right there. C, E, D, A, B. Right there. A, D, B, C, E. Right there. Second to the last one. D, C, B, E, A. That guy. And the last guy, D, C, B, A, E. No, E, A. A, E. B, C. No, I'm on this one. D, C, B. Right there, boom. Okay, so 1, 2, 3, 4, 5. I got 5 that look like that, 2 that look like that, 3 that look like that, 6, 1, 2, 3, 4 that look like that, 1 that looks like that, and it looks like A has won the election. A has the most popular votes. All right, so A, that's my A thing. Take the raw data and put similar things together so I know how many voted each of those ways. And with a little bit of luck, there won't be 10 of them. Okay? All right. Oh, you already have it written down? That's even better. Okay, B, which candidate has a polarity of the first place votes? Okay, so B, the answer is candidate A with, didn't ask us how many, right? With 8 votes. If I could spell volts. How come I'm spelling volts with a W? Anybody know? Oh, I do. It's almost 9 o'clock. That's why I'm spelling it with a W. And I left my can of Coke in my office. That's 2 reasons. C, which candidate has the fewest first place votes? Could we get any more easier than this? Could we? Bravo? A, B, C, D. It looks like Bravo.
Where do you get 8 from?
1, 2, 3, 4, 5, 6, 7, 8.
Oh, okay.
2 from over there, 6 from here. Now, I take my calculator and go 2 plus 6 equals 8. It's 8. It says so right there. We had to add. I know it's disgusting, but that's. What do you say? B? So B, least. Yeah, all right, so least votes. All right. So we've done problem number 1, even though we had no clue what we're doing and we didn't like it. Did we like it?
guy.
No, we didn't
Not
like it.
college algebra,
But
at least.
yeah, but at least we got a answer. All right, number 3. It's much better if they would have done it for us already. You know? They did it for us already. In an election is held for the math department, A, B, C, and D, professors here, E. How many people voted? Okay, well, how many people voted? 5, 10, 15, 21. 21? 21. So we passed the adding test. Excellent. B. Now, if this was a regular math class, we'd have 10 squared times 10 cubed times 10 to the 6th, and we'd have to add 6, 3, and 11 and get 10 to the 11th, but we'd still be adding. Okay, so.
That just makes things more difficult than what it is. So.
Yeah. But, so we practice adding in many different ways, and this time we're practicing. All right. B. How many first place votes are needed to win a majority? Half plus 1, 11. So I'm going to need I need 11 to have a majority. If it comes down to a choice between Agran, who the heck's that, and Diaz, is that Diaz? Which one has more votes? So there's the A guy, which has 8 votes, or the D guy, which has 5. Who wins?
Okay.
Yeah, so whoever that name is. This is it's probably a Spanish name, and that's probably why I can't pronounce it. I had Spanish in 3rd grade and got straight D's there too. Well, that was number 3. We'll go on to number 11. Now, we've already made it all the way up to section 1-4, even though we don't want to say we did. So when we get to problems after 1-4, we'll have to quit. Number 11. This exercise refers to Eureka High School homecoming queen election. There's a preference schedule below. Okay. Using the plurality, I think I got it right there, plurality method, find the winner. All right, well, I guess we just have to go A, B, C, D, and add them up, because I can't. There are too many, and I can't do it in my head. 153 plus 102 plus 55. 310. 202, 108, 20. 330. Well, I can do that one. 270, 175, 155. Oh, bummer, it's a tie. Now what do we do? Find the winner of the election. Notice there's an S there on the A answer. It says winners. So there's 2 winners. We have 2 homecoming queens. Isn't that lovely? Anybody was in high school where that ever happened? 2 winners. When my daughter graduated from Bellevue West, there were 7 valedictorians. She was not one of them. But how can there be 7 valedictorians? How do they do that? You know? When my daughter graduated from a school in Groton, she was 3rd in the class. The only difference between 1, 2, and 3 was in the 10,000th place. So somewhere around there was a difference. Huh?
That would suck.
Yeah, that was the difference between number 1, 2, and 3. Now, the valedictorian was hosed. She had to give the speech, right? Mm-hmm. But all 3 of them got full scholarships to the University of Connecticut. It really didn't matter. Oh. And my daughter went to the Coast Guard Academy. It didn't cost me anything.
Nice.
So sometimes it's okay.
At my high school, they had three
We had 3 valedictorians, yeah. Yeah, when I went to high school, we only had 1. We had a valedictorian and a salutatorian. The salutatorian went in a week after graduation, committed suicide. His girlfriend dumped him, and he ran a car in his garage and was in his garage with the door down and killed himself. So we lost our salutatorian within a week of graduation, before the yearbook was published. So it got into the yearbook that he had died already. That was pretty bad. Anyway, so you have days like that, right? You have to have priorities, you know. Girls are important, and if they dump you, you got to do something about it, like die. No, I really don't think so. Tiebreaker. If there is more than one first place guy, then we need a tiebreaker by choosing an alternative with the fewest last place votes. Ooh. So we had to agree beforehand that we were going to have a tiebreaker, right? And now we're going to find out who has the fewest last place votes. And D has 153 plus 20 plus 160. So D has 333 last place votes. And then the B person has 55 plus 110 plus 175, 340. So the B person has 340 last place votes. So that means D wins. Based on the criteria of if we have a tie, we're going to go with who has the fewest last place votes. But again, in an election, you would have had to agree on that tie-breaking thing beforehand. In our election cycle, in most states, the tie is done by a flip of a coin. In Utah, it's done by a drawing from the deck, highest card out of the deck, on a cut. But in Iowa, I'm pretty sure it's flip of the coin in Iowa. And because, you know, let's pick a town, any town. Trainer. Does Trainer have a mayor? Yeah. Does it? And if 2 guys was running for mayor and they both got 57 votes, doesn't matter which one really wins. No, so they'd flip a coin to see who won, right? Yeah. So anyway, are we done? Oh, I don't know. I haven't read it yet. A different tie-breaking rule. Okay, so this is a different rule. Again, we would had to agree on this before the election. The principal wouldn't have said, well, gee, we need a tiebreaker now. Why don't we go with, no. You had to. So heads or tails. If there are 2 candidates tied for the first place votes, the tiebreaker is a head-to-head comparison between the 2 candidates. All right, so we're going to do a head-to-head comparison. All right, so this is C. All right, so in the first choice, A over D, 153 go to A. In the second case, A over D, 102 goes to A. In the third case, A over D, 55 goes to A. In the next column, A over D, we have 202 going to D. And in the next case, I look at A and D in a comparison, and D wins again, 108 going to D.
Do you need B and D?
Am I hosed?
Yeah. B.
Yeah.
I am just so hosed. Luckily I have a big eraser. Now, I have a big eraser, a minimum eraser. It is the job of the front row to catch problems like that before I go too far away. So, the people in the back rows, it's not that. Yeah.
I forgot to take
I'm not that
Maryland
tired
today,
either.
so.
All right, so we're going to do it again. B to D. In the first case, 153 goes to B. In the second case, B to D, 102 goes to B. In the third case, B to D, 55 goes to D. Third case, B to D, 202 goes to B. In the next case, B at D, 108 goes to B. I think B's got it, don't you?
Yeah.
Okay, next case, B to D, 20 goes to B. Next case, B to D, 110 goes to D. Now I'm running out of room. Next case, B to D, 160B. Next case, B to D, 175D. Next case is B to D, 155D. Okay, so now we're going to have to add up the B's, add up the D's, and see who wins. Okay, so I got 745 for B. I'm going to add up to, now if I knew how many total volts there were, that would be helpful, right? But I don't. Messed it up already. $495 for D, so B wins. But whenever you're doing an election, you're going to have some tie-breaking rule before the election starts, because depending on the tie-breaking rule could depend on which of the two candidates won, and then that would be like manipulating the election, which would be perfectly okay in Vegas, for example, where the mafia is going to manipulate it anyway on the show. 15? Get to turn the page. Consider 721 votes. Right. If there are 5 candidates, at least X voters are needed for a plurality of votes. Find X. Okay. So if I go 721 and I divide that by 5, what do I
You
get?
get 144.2.
144.2. So if I had 145 votes, I could win, right? Because if I had 145, and then the other guy got 144, and 144, and 144, and 144, and I added all those together, that's a 1, 2 to carry 2, 1, 2, 3, 4, 5, that's a 2. 2 to carry 2, 3, 4, 5, 6, 7. I could win with as few as that many votes. Now, if I did that, I'd have to rig the election, but it is possible that I'd only need 145 votes to win.
Why is the top one 145 and the next 144?
I have to win.
Yeah,
Oh, because you need the one.
That's right.
one extra.
Yeah. So I divided out. If I could get if at 144.2 everybody has the same number of votes. And have you ever been on an election where you had 0.2 votes?
No.
Gotcha.
Not yet. Oh yeah, that's not until chapter 3. Don't worry about it. Yeah. But yeah, so that's why I rounded up to 145. That's why I did that. Okay, so that's my A answer. B, suppose that at least 73 votes are needed to have a polarity. How many candidates are there in the election? Okay, so now it's a candidate thing. So I got 721 votes, and I needed 73 to win. Okay, so I could do it two ways. I could go, well, that means 73, and then everybody else got 72, and I could add 72 to 73 until I got to 721.3. I could do that if I wanted to, iteration. But I think if I take 721 and divide it by 73, I'm going to get 9.8767 candidates. So I imagine that if I had 10 candidates in the election, and one of them got that, and the rest of them got one vote less, that would be 9 less, right? So that would be 9 less than 73 times 10, 730 minus 9, 721. So there are 10 candidates in the election, if that's all I need. That'd be my B answer. This is far too much thinking for 9:15. It's a good thing we don't have to do any more problems until I cover more material. Suppose, the C question, suppose that at least 104 votes are needed. How many candidates are there? Okay, so I'm going to go 104. I'm going to divide it into 7 to 1. And I'm going to get 6.9 something. And I'm going to say, well, I have 7 candidates. And then I'll check my work, and I say, if I have 7 candidates, one of them has 104, and the other 6 of them have 103. And if I go 104 plus 6 times 103, I better come up with 721, and I don't. I come up with 722. I have one too many votes. I wonder why.
Was he measure round up?
You have to round down, because that 0.9 is going to screw you over because you don't have a whole person anyway, so you have to count.
So probably I'm going to have, because of the number of votes I have, I'm going to have 5 with 102 and one guy with 103 and one guy with 102 in order to get my number of votes I have. All right. So they tried to hose me over there. Now I look at the next thing, and it says we're going to use the Borda count method. Have we talked about the Borda count method yet?
No.
No, so that means we'll have to go back to transparencies and find the Borda count method. And I'll open, how'd I get over here? Now I did it. Oh.
So are we going to keep going tonight other than what's on the syllabus?
No, but it looks like I hosed myself over pretty bad, doesn't it?
No, just go back to your libraries.
No. I came up on, oh, hit cancel? Cancel. Oh, yes. Brilliant. Totally brilliant. Okay, so now we're going to come up there. If we look at the syllabus, we see that we spend a week on chapter 1, and then we spend a week on chapter 4, and then on Thursday, we take a chapter 1 and 4 test. You see anything bad about that?
No.
Yeah. So I think it'd be better if we snuck some chapter 4 stuff into Thursday so that we get further into chapter 4 on Monday. So we have, say if we started the chapter 1 and 4 test, let's say at 5 o'clock on Thursday, then whenever you got done with it, we'd have to go home, right?
5 o'clock? We're another class at 5 o'clock.
Well, when do we start? 8
Eight.
o'clock, yeah. I was hoping. Anyway, so if you started it, but if we still had to cover sections 4 and 4.5 and 4.6 on Thursday, then we couldn't start the test until we were done with all the homework. Now we're starting the test at 9:30, and we're here until 10:30, 11, 12. My wife's in Connecticut, so it really doesn't matter. I can stay until midnight. You know, that's not a real issue here. So, but I'm thinking that it'd be better if we don't stop and we do section 1.4, maybe 1.5, so we
If
can.
we're out by 10 o'clock, that's fine.
Yeah. So we'll pass out the quiz at quarter of. Is that what you're telling me? Okay. All right, gotcha.
Is it an in-class quiz? Is it a take-home quiz?
And can we use our books on our quizzes and tests?
No, definitely not. Now, let me explain this without using any French.
Not that comfy.
Okay, so we're back on. I'm looking for section 3. So this is Borda count method. Okay, good. And we're supposed to cover Borda 3 anyway. Each place on the ballot, it has an assigned number of points. So 1 point for last place, 2 points for second, and so far, and so if there's 1,000 candidates, the first place vote would get 1,000 votes. Now, that wouldn't work very well. Then we tally up the votes of each candidate separately, and the candidate with the highest total is the winner, and this is called the Borda winner. Probably after Borda, Michigan. That's the only place I know there's a Borda.
Quick question.
Yeah,
What kind of math is this anyway? Like, is it statistics, or what are they, like,
this is modern math.
but I mean, like,
Liberal arts.
but I mean, like, no, but I mean, like, this specific type, I mean, like, this,
I thought math
But-
we were gonna learn
like,
addition, subtraction,
Well-
multiplication, division, algebra,
but, like,
geometry.
I'm just curious, like, when you're counting votes and stuff, I mean, is that part of statistics, like, kind of, like, is it, or is it just kind of, is all this stuff kind of like math that just doesn't fit in a specific?
Too many questions.
See, when they told me I was gonna take math, like I said it's gonna be addition, subtraction, multiplication, free algebra, algebra, geometry.
Mm-hmm.
And
We've,
this is
we've,
totally opposite.
we've added so far, right? We've divided so far, right? We've even subtracted once. I mean, we're meeting your expectations. Yes. And not only that, but you're getting credit for it. And how many football players do we have in the room? Oh, shit, you know, darn. You know, I don't understand. Anyway, so to answer that question, it's part of this book right here by this author. It's in a 7th edition, Math for Liberal Arts. We actually teach a Math for Liberal Arts class at Iowa Western. I don't do it. It doesn't cover any of this. Okay. So anyway, I'm being recorded, so I can't answer the question. Is that fair? So anyway, we're gonna tabulate the number of first, second, third, and fourth place, give a point value. Okay, so we have 4 choices. So we're going to have 1, 2, 3, and 4 points. So there's 14 votes times 4 is 56, times 3 is 42, times 2 is 28, times 1 is 14. We do that with a number of 10s, number of 8s, 4s, and 1s. So we do all that together, and then we're going to add the number of points the A candidate has. 46, let's see, 56, 66, 66, 70,
64.
74.
Yeah.
74, 78, 79. Oh, 79. Lucky guess. Total luck.
Alright, it works, doesn't matter.
Yeah. Anyway, so we add up the total number of votes, and B is now the winner. Do we remember in the math club election who won the last time?
A.
A won. So in the first way we counted votes, A won. In the second way we've counted votes, B won. Before the end of the night, if we have enough time, every single candidate's going to win. Okay, so that's the cool part. So the Borda winner is Boris. All right, so now we've had to multiply and add. Yes. So what's wrong with this method? In contrast to the Plurality Method, the Borda method takes into account the voter's preferences. On face value, it seems like an excellent way to take full consideration of the voting preferences. The next example will illustrate a problem. Why? So the last principal of Washington Elementary School just retired, and we're going to have a new principal. And we rank A, B, and C like that. Well, A should probably win. He's got the majority of the votes, right? These guys only have 5. He should be the winner. But if we do, so he's got the majority, he should win. And he's the Condorcet candidate. He has 6 first-class votes. He should win. Head-to-head comparison, he wins, right? And in the Borda count method, what happens? Tell me what happens. It's not going to tell me? It didn't tell me.
Not yet.
Somebody else is going to win. I know somebody else won, but it didn't tell me. Bummer. Okay, back to homework. All right, now that we know what Borda count method is, now we can do it. Okay, so we're doing number 17. The math department exercise, blah, 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 blah. Use the Borda count method to find the winner. All right, so we're going to add, we're going to have 1, 2, 3, 4, 5 points possible. And we're going to have 25 going to A. And we're going to have 20 going to B. And 15 going to C. And 10 going to D. And 5 going to E on the first row. Second row, we have 15 going to A. We have 12 going to D. We've got 9 going to B. We've got 6 to C and 3 to E. E's really in trouble, I think. All right, next row. 5 again. Okay, so C's got 25, E's got 20, delta 15, alpha 10, bravo 5. Okay, next one. We have 3 again, so D has 15. C has 12, B 9, E 6, A 3. Next row we have 2, so D has 10, C 8, B 6, A4, E2, and the last row we have 3, which is B for 15, E for 12, A for 9, C for 6, D for 3. All right. So now we're going to add up the A's. 25, 15, 10, 3, 4, 9. Did you say something that I missed?
No, I was counting.
B. Oh, you're counting out loud?
Mhm.
Oh, that's what calculators are for. 20.
Well, I use my phone and it sucks to calculate on.
Oh,
I'd
well.
rather use my brain.
Okay, well, that's good. Brain's good at work too. 5, 9, 6, 15. C. 15, 6, 25, 12, 8, 6. We're Hose City here. Oh, I got an idea. View, zoom. Was that brilliant? Totally brilliant. So D, 10, 12, 15, 15, 10, 3. And echo. 5, 3, 20, 6, 2, 12. All right, now we can use, well, we can use our brains or we can use our calculators anyway. All right, so for the same election, we had A winning before, we had B winning before, and now we have C winning. Isn't that lovely? So we have 3 different winners. Now we have to figure out some way how to make D and E win. Suppose that before the votes are counted, candidate E is declared ineligible. Find the new preference schedule for the election without E. Okay, luckily I can have plenty of room. Can I have plenty of room, or you want to see what's up there? So we're going to do the B part. All right, so E isn't there anymore. So I have 5 voters that go A, B, C, D. I have 3 voters that go A, D, B, C. I have 5 voters that go C, D, A, B. I have 3 voters D, C, B, A, 2, D, C, B, A, 3, B, E, B, A, B, A, C, D. Because these 2 are the same, we can change this to a 5, and we can get rid of that row. So there's my new preference schedule of first, second, third, fourth places. Okay? Use the Borda count method to find the new winner. All right, so I'm going to have 1 point, 2 points, 3 points, 4 points. Okay, so I'm going to have A gets 20 plus 12 plus 10 plus 5 plus 9. B gets 15 plus 6 plus 5 plus 10 plus 3 plus 12. C gets 10 plus 6. How can that be 6?
It's not 6, it's only 3.
This is, yeah, this is a 3. 3, I'm on C, plus 20. I'm on C. This is 20 plus 3 times 5, 15 plus 2 times 3 is 6. And then D gets 5, 9, 15, 20, and 3. Now, how could I do that? Well, I just picked the number that was missing, right? I'm supposed to have a 5, 10, 15, 20, and a 3, 6, 9, 12, and a 5, 10, 15, 20. Without seeing the other numbers, I generated those guys. All right. And I would bet that D is going to win, just so I have a new winner of the election that's different than any other one. 20 plus 12 plus 10 plus 14. 56. 15, 21, 12, 48. 13, 35, 6, 54. 5, 9, 15, 23, 52. No, A1. So when E drops out of the race, A is going to win. A did not win the time before, right? It was
No.
C that won the time before. This cancels our fairness criteria, right? The guy that won before should have still won, even though the candidate went out. The results of A and C implies a violation of which fairness criteria? Which fairness criteria? Give you a fairness criteria. Now we gotta go looking in the book to figure out which fairness criteria we've gotten violated. Okay, so it's not concordant because that's a head-to-head thing. Majority of criteria. I think it's the majority of criteria. The guy with the most first place votes should have won. I think I'm going to go with that one. Yeah. So I would go with D, majority criteria, just because it's late in the day. All right.
Right, what?
I don't know.
No majority what?
Criterion. That'll teach you. You have to have it spelled right too? Wow.
No,
No,
that's
this is a
like
math.
Your C
This
was
is a-
like a parentheses.
Oh, it does? Okay. Did that help any?
No,
That hoses you over more?
no, I got it figured out now.
I got to figure out, okay, we're good now?
Now we're good.
Yeah. Okay, well, that was 1725. All right. Okay, we'll do 25 and then we'll have to go and do the quiz. So we can get out at a decent time. An election is held, A, B, C, and D, 50 votes. The winner of the election is determined by Borda count method. Suppose you have the following points, A, B, D. The total points for C are, okay, so we've got 50 voters. And we've got 115 for A, 120 for B, 125 for D, and we want to know how many C votes there are. Okay. Okay. If there's 50 voters, that means I got 50 first place votes, right? And I've got 50 second place votes, and I've got 50 third place votes, and I have 50 last place votes. And so that's 200, 300, 400, 500 votes. Okay, so if I have 500 votes, and I subtract 115, and I subtract 120, and I subtract 125, then I get some number, and that would be the number of votes that had to be for C, right? 500 minus 115 minus 120 minus 125. Oh, 140 for C. To answer the question is, what good is this if your major happened to be elementary education? Then these might be topics you could add to your third grade math class. How exciting would that be? Okay, so at that point I think it's time to pass out we'll do a Control Alt.